During this video, we are going to show you how to classify chemical equations based on the form in which they are stated. First of all, we have to remember what is a chemical equation. In an equation or a chemical equation gives the chemical formulas of the reactants on the left side of an arrow and the products on the right side of the arrow. Everything that you have before the arrow is what is going to be interacting in order to form the products, which are the ones that we have on the left side. So for example, here, carbon and oxygen are the reactants and CO2 is a product, okay? So what we have at the beginning of the arrow, it's called reactants, and what we have on the right side of the arrow, we call it products. And normally what we have in the arrow are going to be conditions of the reaction, temperatures, pressures, and catalyzers that you may be adding to your reaction in order that the reaction takes place. Now let's see which are the different types of equations that we can have. Chemical reactions can be classified as combination or synthesis reactions, decomposition reactions, single replacement or single displacement reactions, double replacement or double displacement reactions, and combustion. Let's see the different examples of them, okay? In a combination reaction, we are going to be, as the name says, combining. We are going to be combining two reactants in order to form one single product. This is called also synthesis, okay? So in a combination, we have A plus B that reacts in order to form AB, okay? We have two reactants, one single product. In a decomposition is the opposite of combination, okay, or the opposite of synthesis. We are going to have one reactant that splits in order to form two products, okay? Then we have single replacement reactions. In this case, what we are going to have is we are going to be switching the place of one of the reactants in order to be with the other product, okay? If we try to write it in terms of a formula, we have A plus B and C. After the reaction takes place, B will go with A. We're going to have AB plus C, okay? In a double replacement or double displacement reaction, as the name says, two of the reactants are going to be switching their places. So we have AB plus CD, and after the reaction takes place, we are going to have AC plus BD. Okay, B and C switch their place. And finally, combustion reaction. In this case, we must have four things in order to call it combustion. We must have carbon, oxygen that react in order to form CO2, water, and energy, okay? If we have something missing, it is not a combustion reaction. We must have the four things: carbon, oxygen, CO2, and water. Let's see some examples in order to see if we understood the different types of reactions. Okay, these reactions are not balanced, and we are not going to be taking care of the balancing. Later, we're going to see how to balance chemical equations. What we just have to look for is the type of reaction that it's happening. Okay, so in the first one, we have oxygen plus hydrogen that reacts in order to form H2O. So we have two reactants, one product. If we transform it into letters, will be something like this. So this is a synthesis or combination. We are combining two reactants in order to form one single product, okay? In the next example, we have NaCl, which is something as AB. We have two different elements, and we have calcium, which is C, and NO2, that is a polyatomic ion that we can consider as D. After the reaction takes place, as you can see, we are going to be switching the places of B and D. Okay, now we are going to have AD plus BC or CD So in this case, it's a double replacement reaction, okay? In the next reaction, we have copper plus nitric acid, okay? We can write, or we can consider as NO3 as a polyatomic ion, so as one single element, okay? So we have A plus B and C. After the reaction takes place, C goes with A and B stays alone. So this is a single replacement, okay? Then we have sodium plus chlorine, and after the reaction takes place, we have only NaCl. So this would be a combination. Or synthesis. Okay, here we have another example, which is C6H12O6 plus oxygen reacts in order to form CO2, water, and energy. Okay, here we have the carbon, we have oxygen, we have CO2, water, and energy. So this is combustion. Okay, this is what you have to do. Just check every time that you are determining the types of chemical equations, check which are the elements that you have and how they are moving in the reaction in order that you can define if it is single, double, combination, combustion, or decomposition, okay? I hope you understood this.